very big welcome from myself and my trusty sidekick, Coco. She says this is only her. She says this is only her second lesson, but Coco is actually very experienced. But she was with the grade 7s before, but now she's joined us in grade 12, which I'm really, really pleased about because Coco is my good friend. So yeah, it's awesome to have you with us again, Coco. Yeah, let's get started. All right, so the last time that we were together, Matrix, we were talking about the chord theorems and we were speaking about the angles on the inside of circles, okay? This time, I'm going to extend us beyond that and we're going to talk about tangents and we're also going to talk about cyclic quads, okay? And I think this is sort of the part where it starts to get a little bit trickier. Okay, anyway, so again, let's start off with revising what it is we're supposed to know. Rora-san, do you have a question?
Hey, ma'am, I'm sorry to disturb, but like, these lessons are recorded, right?
Yes, absolutely. Absolutely.
Okay,
so yeah, so you can go back and watch it again if you need to or you want to. Okay.
Thanks.
All right, no problem. So let's first of all start off talking about tangents, right? And before we jump into the tangent theorems, let's just clarify, what is a tangent? What is a tangent, Matrix?
Is a line. The line that touches the circle only at one point.
That's it. Okay, Pumla, that was very good. All right, so I don't know if the rest of you heard what Pumla said, but it's a line that touches a curve at one point only. Okay, so a line can be a tangent to a circle, but a line can also be a tangent to a function like a parabola. Okay, so a straight line is a tangent, and there are 3 different tangent theorems that we need to remember and be able to identify. Okay, so the first one is that the diameter or the radius is perpendicular to the tangent. Okay, so that's what I've got here in picture number 1. All right, so either if it's a radius or if it's an entire diameter, it's always going to be perpendicular to the tangent, and that's exactly what we would say. Okay, so we would either say radius perpendicular to tangent, or we would say diameter perpendicular to tangent. If you want to, you can abbreviate that. So, you know, you're more than welcome to write this, radius perpendicular to tangent, as your reason. Okay, so that you have to be told though that AT or OT is or that O is the center of the circle and that passes through there. All right, and then that would be fine, and that BT is a tangent. Then the other thing that we have is tangents from the same point. Okay, so the same point is this one over here at A. All right, so that tangent touches the circle there at Q. This tangent touches the circle here at P. And what we would say in this case over here is that AQ and AP are equal to one another. The reason, tangents from the same point or tangents from a common point. All right, if I then joined, I'm going to do it rather badly, I'll try not to. If I then joined Q and P with a straight line, what could I say about this angle over here and that angle over there?
They are equal.
Why would they be equal, Pumla?
I mean, I will construct therefore I will say triangle.
You don't have to construct, anything. All right, so once you've already stated that AQ is equal to AP, and you've provided your reason and you've said that they are tangents from the same point, you would then conclude that this angle here at P and that angle there at Q, angle P equals angle Q, because they are angles opposite equal sides. Remember, triangle AQP is now isosceles. All right, but we're not allowed to use the word isosceles as our reason. We've got to say angles opposite equal sides. So bear that in mind, okay, Matrix, because that is something that does come up fairly regularly when you've got tangents from the same point. And then the last one. Sorry, is there a question?
Yeah, remember when you ask if the angles are equal, why the angles equal? Is it wrong to say because angles from the same tangent are equal?
Yes, because the reason, you see, the thing is that tangents from the same point proves that two pieces of line are equal to one another. All right. So if you're saying, so you can't say P equals Q, tangents from the same point. Okay, because tangents from the same point proves that two lines are equal to one another. Okay, and lines and angles are not the same thing. So you would first have to say AQ equals AP, tangents from the same point. And then after that, you could say, therefore, P equals Q, angles opposite equal sides. Okay, that would be, do you remember the last time we were talking about the correct order that things need to go? And this is just another one of those examples where, you know, if you're now going to go and I don't know, jump into the swimming pool, you know, you're first going to put on your swimming costume and then you're going to get into the water. You know what I mean? You're not going to jump into the swimming pool with all your clothes on and then get out and then put your costume on and then jump back in. You know what I mean? There's an order in which things have to happen. So if something hasn't been given to you, or you first have to so in other words, if something hasn't been given to you and you want to use it, you first have to prove that it's true. Okay. All right. And then there's this one over here. Yes, Pumla? Go for it, Pumla.
If we constructed O in the middle, so that we can have two triangles.
Pumla, hang on a second. Pumla, it's not okay to construct. Okay, so when you are answering riders, when you are answering geometry questions, you are never, ever, ever, ever constructing. The only time you will construct is when you are proving a theorem. Okay, the only other time in paper 2 that you can draw a line is in analytical geometry, where we sometimes draw the third side of a right angle triangle. There you might have to do a construction, but you will never, ever, ever construct in one of these diagrams. So if you have a look at, like, we're going to go and do this one as an example, you will never need to construct anything. Okay, and it's the same one. If I look at this diagram over there, everything is constructed for you. All right, so you mustn't be constructing. Okay, it's only when you're doing the proof of a theorem, that is when you construct, and at no other time. Okay. Okay, then tan chord theorem is one of those that I think sort of trips a lot of people up. So when we talk about the angle between the tangent and the chord, we are talking about this angle over here. So here is the tangent, just highlighted. There is the tangent, TA. There is the chord. Okay, so the angle between the tangent and the chord is going to be this angle that I have colored in pink over here, is equal to the angle in the alternate segment. Okay, so what happens here, Matrix, is that this line, TB, cuts the circle into two segments. This tiny piece over here is the minor segment, and everything else to the left of this line is the major segment. That's why we call it the other segment. Right, so the angle between the tangent, TA, and the chord, TB, is equal to the angle in the alternate segment. All right, so that means that it is equal to angle C. All right, so over here, we would say that angle ATB is equal to angle C. And our reason, tan chord theorem. And it works back the other way as well. Okay, so in other words, you know, if I know the size of this angle over here at C, I can work not backwards, but I can say, I can go and I can say, well, BTA is also going to be 60 degrees because of tan chord theorem. Okay. Okay, no CATM, but that's fine. Don't worry. We're glad to have us. Glad to have you with us. Okay, so let's have a look at this example before we carry on. We have been given circle ABC with circle center O. TAN is a tangent to circle ABC at A. TAN, okay, so that's line TAN, is parallel to line BC. Determine the sizes of angles A, B, C, and D. Now, this is something that I just want to impress upon. Matrix, the very first thing that you do is you read the information. Don't look at the picture first. Read the information. Get a highlighter and highlight the important words, okay? Because those words are what is going to inform which theorems you're going to be working with. Okay, so the thing they've told us is that first of all, there's circle center O. So now you think to yourself, okay, there's a circle center. I've been given this. What theorems do I know about the circle center? Okay, so Tumelo, name one.
For the second sentence, angle at the center is double angle at the circumference.
That's it. Okay, so that's the first one. There's another thing that we know about the circle center. Okay, if there's a diameter and the line goes through it, then maybe there could be an angle in a semicircle. All right.
Yeah,
so,
92.
but in this particular case, that isn't true. Okay. Then we read on and we see the word tangent. Okay, now our minds are buzzing. When we see the word tangent, we think to ourselves, tan chord theorem. Are there two tangents? Could there be tangents from the same point? Right. What's the other thing that we could think about? What's the third thing we could think about when we see the word tangent? So we've spoken about tan chord theorem, tangents from the same point. What's the other tangent thing that we need to be aware of?
Is it
radius?
The radius is? That's
Perpendicular.
it. Lovely, Tobile. Okay, so the radius is perpendicular to the tangent. Okay, and that's how you've got to think about these things. All right, so the minute you see those keywords, you say to yourself straight away, what theorems do I know? All right, then they tell us that line TAN is parallel to line BC. So now you're going back to grade 8. All right, what do you know about parallel lines from grade 8? What sort of angles?
alternate angle?
Beautiful, alternate angles. What else?
Corresponding angle?
Corresponding angles and even co-interior angles. Absolutely. Okay, so if they have told you that lines are parallel, you can bet your bottom dollar that there's going to be either co-interior or alternate or corresponding. Otherwise, why put them there? So there's lots of angles going on in this picture for us to work with. All right, so now the first thing that they want us to do is work out how big angle A is, right? So now if we have a look, we can see that angle A is this angle over here. All right. Anybody want to offer an answer for A straight away?
It's 58 degrees.
It is 58 degrees. Why is it 58?
The tan chord theorem.
That's it, Jamie. Can the rest of you see that?
Yes.
You sure?
Yeah.
Okay. All right, so I'll highlight it just in case there are some people that are shy to say yes. There is the tangent. There is the chord. Put your fingers at A and C and follow the line from A and C to the circle. Okay, and that means that we end up, oh, that's a very skew line, I beg your pardon. It means we're going to end up there at A. So we've got tan chord theorem. That's great. All right, so that's the first one. This is nice and easy for us. We would get a mark for this and we would get a mark for our reason. Okie dokie. Next one. Now we need to work out B. Anybody got an idea as to how we would work out B? That's right, Lebogang. Sorry, I was just looking in the chat. I beg your pardon, who was going to say something?
Yes, Mila. I was going to say that, sorry. I was going to say that B is half of 58 because of angle of the circumference and all sort of stuff.
Okay, so you're right, Tumelo, you just got it the other way around. Okay, so in other words, B is going to be twice as big as A. Okay, the angle at the center is 2 times the angle at the circumference. So you were almost 100% perfect. Okay, Okay, sorry, I'm struggling to pronounce that name. Perfect. Okay, so you said it is 116 degrees. Lovely. Our reason, angle at center equals 2 times angle at circumference.
Ma'am, can I
Yes,
ask a
Coco.
question?
Of course.
Would it be safe to say that the angle at the center will always be bigger than the angle at the circumference in this particular theorem?
Yes. Yes, the angle at the circle will always be, in the center will always be twice the size of the angle, but it has to be subtended from the same points. Okay, so
Yes.
in other words, angle B is subtended by chord AC. So provided chord AC or arc AC subtends the angle at the circle, then B will always be twice of A.
Okay, all right.
Okay.
Thank you very much.
No problem. I'm glad you asked. Okay, so that's A and B done. Now we need to do C. So angle C, guys, is all the way down here. Let's put it in a different color. There's C over there. Okay. Can someone tell me what you think C is?
58.
Good. And why is it 58?
Alternate angles.
That's it. Perfect. Okay, sorry, I didn't see who was talking. It was Kutlana. Sorry, what's your name?
Udrano.
Oh, well done. That's excellent. Well done. Alternate angles. And what must we not forget to name when we write alternate angles as a reason, Matrix?
The parallel.
Parallel lines, absolutely. Okay, so here we can say it's because TA is parallel to BC. Okay, good job. All right, well, we're flying through this. Excellent. And then the last one they want us to work out is D. Okay, so D sits next to C, Matrix. It's over here. Anyone got, yes, Tundle, where to go for it?
Ma'am, I wanted to ask that if you don't write TA parallel to BT, do they still mark the thingy wrong? Your reason?
You know, Tundle, where to, they might just, because you might lose the mark, because by the time you get your matric, something like this probably wouldn't be worth 2 marks. It would be 1 mark. All right. So yes, it would have to be the reason with, sorry, the size together with the reason and the parallel lines. So yes, when you were in grade 8 or grade 9, then they probably wouldn't have been as strict, but at matric level, yes, they would expect you to have the parallel lines there. Okay, so yeah, and I mean, you'll see when we move on and we start talking about the proportionality intercept theorem, it's another place where you have to name the parallel lines, and if you don't, then they penalize you for it. But I'll try and emphasize that to you as much as I possibly can. Okay, so Ntando says that D is equal to 64. Ntando, why are you saying that? Why is D equal to 64? If you want to put something in the chat, Ntando, that's fine. Or if you want to unmute yourself and talk, up to you. Why is it 64? Does somebody else think that it's not 64 and that it's maybe something else?
Ma'am?
Yes, Lebogang?
Ma'am, isn't it that OA is perpendicular to TN, making DC as a whole a right angle triangle? Right angle.
Indeed. Yes, absolutely. So this entire thing here is a right angle. Good. Keep going. So tell me what to write. I love it.
Ma'am, D equals to 90 minus 58.
Perfect. And your reason?
I'm not sure the reason, how to phrase it.
That's fine. Radius perpendicular to tangent.
Okay.
Okay, perfect. Well done. That was excellent. Okay, so now we've got to take 50 away from 90. So is that going to be 64?
32.
It's going to be 32. It's going to be 32. Okay, good job. Well done.
I think Lihume might have beat us to that answer. She might have
yeah,
she
it
had
does
it in
look
the
like
chat
it.
way, like
Yeah,
months
like
deleted,
ages
so
ago. Okay, so now Casey's
yeah.
asking a question as well. Couldn't we also find it by using angles around a point? Casey, I suppose you could. But the thing is that what you also don't know is you also don't know how big this angle over here is. Hang on a second. So you don't know how big this angle is. Although I suppose you can work it out. I mean, you could possibly do that, but it's going to be a lot more work. So what I would say to you is I would rather try and do things in the shortest way possible rather than in the longest way possible. Okay. Valerie, you want me to explain how we got D again? Not a problem. Valerie, can you see the orange lines? Okay, so this orange line from A to O is a radius. Okay, and then this orange line over here is your, whoopsie, is your tangent. Okay, so your radius is perpendicular to your tangent. So where I have drawn this box over here, that is a right angle. Can you see it a little bit better now? Okay, so it's this angle over here that's going to be 90. C plus D. Okay, because the radius is perpendicular to the tangent. So that's what we're stating over here, radius perpendicular to tangent. And then we can take 58 away from 90 in order to get 32. Okay, Valerie?
Can I ask a question, Tomato?
Yes, of course, Tomato.
Would it be wrong to say that since we have C and A, whereby we say 58 plus 58, then we get 116, then you say 180 minus 116 because angles are on a straight line?
Okay, but now that's a very good question. But the thing is that how big is this? We can't assume that these are going to be, they can't, you see, the thing is we can't always assume that they're going to be the same size, all right? Now, in this particular case, because these lines are parallel, the angle in the alternate segment, all right, ends up being alternate to angle C. That's why A and C are equal. But you could have a situation, don't worry, Hope, we're going to come, I won't forget about you, we'll come back. We could have a situation like this. Okay, let me just go all the way over to the side here. Okay, now, if you have a look at this particular diagram, all right, I can't assume that T1 and T3 will be equal to one another. Right? I don't know that line AC is parallel. So that's one diagram. Let's just try and draw something else.
But then in this case, we have...
Okay, so the way that it works with tan-chord theorem is that this angle over here, that's between the tangent and the chord, is going to be equal to the angle in the alternate segment over there. In this particular case, what we've got is that this line over there and that one over there were actually parallel to one another. But as it stands right now, if we look at the diagram here, this angle that I've colored in black, it's not going to be the same size as that angle over there. All right, so it's just because of the parallel lines in this diagram that it is. So what I'm trying to get at is your answer will be correct for this particular problem, but you are making an assumption, and the assumption is that this angle over here is exactly the same size as D, okay, which it will be for this particular question. If you knew this angle that I had colored in orange, if you already know how big it is, and D was the only thing that was missing and you had C as well, then yes, by all means, you could use angles on a straight line. Okay, but one of the worst mistakes that you can make in geometry is to make assumptions about things being equal when they're actually not. Okay, but in this case they are, but they're not always going to be. Does that answer your question?
And can I ask something?
Of course, Noxie, go for it.
Ma'am, what I did was do the angles that ma'am, that TAN is equals to 180. And what I did is I said 58, 180 minus 58 minus 58. And then it gave me an answer, and I divided it by 2, and it gave me 32 degrees.
Absolutely, it will in this case, Noxie. It will, because D and the angle that I've colored in orange for this diagram are equal to each other. All right, so it works for this diagram, but it's not going to work for all diagrams.
Yes.
Okay, the reason that it works for this diagram is because the tangent and line BC are parallel to one another. That's why it works in this diagram. If we were doing another question, it may not work if line BC and line TN were not parallel to one another. So it's better for you to rather say C plus D adds up to 90, because we know that that's definitely true. If OA is a radius and TN is a tangent, then C and D will always add up to 90. We might see in the next question that we do, maybe this will sort of clarify itself a little bit. Okay, but you've just got to be careful about making assumptions about things rather than working with what's 100% true. Okay, so let's go and have a look. We've got a traffic light over here on the side. Okay. What I'd like to know is, would you like an opportunity to be able to work through this yourselves, and Coco and I can be quiet and maybe just support you a little bit? Or do you want me to kind of take you through the problem? What do you think is better?
We can have a vote, guys. Thumbs up if you want to
Thumbs
do it
up if you want to do it yourselves.
Thumbs down if you want ma'am to help. Can we do that in the chat quickly?
Awesome. Yeah, what a great idea. Thanks, Coco.
Oh, okay, I'm getting a lot of thumbs up. So I think we might have to do a majority vote here, because
we'll have to do a majority vote here.
I'm really sorry for all those who say thumbs down, but I'm seeing a lot more thumbs up than I am thumbs down. Yeah, I think the thumbs up might have it. But for those of you who say thumbs down, don't stress, try your best, and then Lee's going to go through it anyway, so you will be able to see what it looks like afterwards.
Absolutely. And if you need some help getting started, then that's what Coco and I are here for. Okay. All right. Lovely. I'm so proud of you that you're willing to give this a try on your own. That is amazing. Let me make this a little bit bigger for you so that you can clearly see everything that's going on here. All right. So there you go, Matrix. Okay. Get started. Remember, the first thing that you do is read the information. Okay, and Coco and I are right here if you need us. We'll give you guys 5 minutes. Okay, so I'm just going to help you a little bit. All right, there's a couple of things that they've told us here. All right, O is the center of the circle, STU is a tangent, chord BC and chord TC are equal to one another. I don't know, whoopsie daisy, I don't know if you guys remember what that means. I did mention this on Tuesday. I won't say any more about it now. ATC is 105, so that's this angle over here. That's ATC, also T2. And CTU, okay, so that's this angle here. Let's just use another color. It's 40. Okay, so I'm going to put that on there for you, and now you guys can go for it. Go for it, September.
I was asking, are lines AC and SC parallel?
No, no parallel lines in this case. Okay, September. Just a little bit more difficult than the one that we've just done. Inihle, you are very clever. Yes, I'm so glad you asked that question. I'm jumping up and down right now. Well done. Well done, Inihle. Perfect. You are on the right track. Go for it, Kubuano.
Ma'am, so like OC and OB are equal, right?
Correct. OB and OC are equal to one another. What's the reason that they're equal? Because they are?
Did you hear me?
I did. They are equal to one another. OB and OC are equal. You're 100% correct. But now I'm asking you, what's the reason that they're equal to one another?
They're both radii.
Perfect. Okay, you got it. Well done. Lovely. Okay, immediately you're asking another question. Let me just have a look at this. The exterior angle. Okay, so immediately, in order for there to be, what are you talking about the exterior angle of? The exterior angle of a triangle or the exterior angle of a cyclic quad? You just have to tell me a little bit more what exactly you mean immediately. Okay, so immediately, the angle that is on the exterior of the cyclic quad, the one that's labeled as 40 degrees, would not be considered an exterior angle of a cyclic quad, because in order for there to be an exterior angle all right, that's either equal to the opposite interior angle in the case of a cyclic quad, or equal to the sum of the two opposite interior angles in the case of the triangle. The line, or one side of the triangle, or the cyclic quad has to be extended. So just very quickly, sorry everybody, sorry. Just very quickly, I'll just do that, and then I've got a little bit of space here on the side to answer you immediately. All right, so now I'm going to draw a triangle, probably very badly, you'll have to forgive me. Now, immediately, if I decide to extend the third side of this triangle, that exterior angle over there will be equal to the sum of these two angles over here, right? But if I have a triangle like this, and I do that, that's not an extension of one of the sides. Okay, so because it is not an extension of one of the sides, this angle over here will not be equal to this one plus this one. Okay, and it's the same thing with a cyclic quad. So if you've got a cyclic quad, whatever sort of quad shape it takes, as long as one of the sides have been extended, then the exterior angle will be equal to the opposite interior angle. Okay, so here, line TU is not an extension of one of the sides of the cyclic quad. So no, 40 degrees is not going to be equal to, is T equals to B. Opposite angles of a cyclic quad, Ntando, opposite angles of a cyclic quad are supplementary. Okay, cyclic quad are supplementary, not equal necessarily. Okay, so the word supplementary means they add up to 180 degrees. Okay, so A1 plus A2 adds up to the supplement of 105, if I can put it that way. Okay, Mihle, no problem. That's it, Ntando adds up to 1. Yes, there you go, Ntando, that's good. Quite right. Oh, you guys are doing so well, hey, I'm so impressed. Are you ready for us to talk about it? Given you enough time? Yes, the whole of angle B is 75. Okay, Tumelo, how did Ntando get 75? Awesome. Okay, so let's move on and let's talk about that. All right, now what I want to do, we'll quickly get there, okay, Ntando? That's a good question. Sorry, Tumelo. All right, so angle A2. So angle A2 is going to be equal to 40 degrees. And our reason here, matrix, would be tan chord theorem. Okay, so we all saw that line CU is the tangent, TC is the chord, and angle A2 is the angle in the alternate segment. All right, then Imihle, you are on fire today. Imihle said that angle A1 and angle A2 have to be equal to one another. And our reason for that is because of equal chords subtend equal angles. Do you see how it comes up very rarely, but it does. So it's a nice thing to know, especially for this question. Yes, Lebogang, go for it.
Ma'am, I want to ask a question, right?
Of course.
A1 plus A2 should equal 105 because of angles of a cyclic quad. That's the reason I used to get A1.
No, Lebogang, okay? When it comes to a cyclic quad, now I'm afraid I've kind of done you guys in here a little bit. There's two things about a cyclic quad that are true, okay? First of all, the two angles that are next to one another are not necessarily equal. So in other words, in this situation here, okay, unless all of them are 90. So over here, those over there are not necessarily the same, is not necessarily the same size as T2, is not necessarily the same size as B1 plus B2, is not necessarily the same size as this over here, right? The deal with cyclic quads is that the opposite angles are supplementary. So in other words, what we see to be true here, Lepokang, is that if we add A1 and A2 together, and we add that to C1 and C2 and C3, they will add up to 180 degrees.
Okay.
Okay, so angle C and angle A are supplementary, they add up. So that means that if T2 is 105, it means that B1 has got to be 75, like Ntando said. Okay, Aisha, you've got your hand up, go for it. What's your question, Aisha?
Ma'am, I have a question. So about the equal chords obtain equal angles, I'm not understanding how the chords are equal.
Okay, that's fine, Aisha, no problem. It was something that was given to us, Aisha. All right, so it's not something that we made up. It's because of this specific question. They said to us here that chord BC, all right, I'm just highlighting it for you here, Aisha. Chord BC is equal to chord CT, all right? So that was a special condition that came with this particular diagram. Right, so because they told us BC and TC are equal, it means that those chords will subtend equal angles at the circle. It's kind of like equal chords subtend equal angles, Aisha, is an offshoot of angles in the same segment. That's where it comes from. So in other words, what you've got, and with angles in the same segment, I'm just going to quickly try and draw this for you on the side over here, right? If you've got your bow tie, now let's say that point over there is joined to this one over here, right? The reason that this angle over here and that angle over there are equal to one another is because this piece of arc or this straight line subtends both of those angles. Right, so now what we see with equal angles subtend equal chords, all they've done is that they've pulled those two triangles apart. So now let's say you've got this chord over here that subtends that angle at the circle. And let's say you've got another chord over here that subtends this angle here at the circle. If I say that that and that are the same, it's like me putting them on top of one another and it being over here. Okay, that's why these two are equal. So when they've pulled the two triangles apart, they've separated their bases, that's when we say equal chords subtend equal angles. If they're sitting on the same base, that's when we say angles in the same segment. Does that make sense?
Yes, ma'am, thank you.
Pleasure. Okay. Coco, are we on top of what's going on in the chat? Is everybody all right there, or?
I'm hoping so, ma'am. We were just explaining why angle A1 is not the one that's equal. Is it A1, ma'am? Could you just move back?
Okay, I'm just going to go back.
Yeah.
There we go. There we go.
How A1 is not the one that's 40 degrees because of the tan chord theorem, but A2 rather.
Correct, correct. So if you want me to go through that again, I'm obviously more than happy to do so. All right, so what we can see here, Matrix, here is your tangent, TU. Here is your, oh, terribly drawn. I beg your pardon. Sorry, it's actually not as easy to draw on here as it looks. Okay, so you'll just have to be patient with me. Okay, so there is the tangent, okay? This line over here is the chord. All right, so the angle between the tangent and the chord subtends the angle in the alternate segment. So let me just get rid of this. If you put your fingers at C and at T and you follow CA and TA to A, you will see that it's going to be angle A2. Okay, can you see that now, Matrix? Is that a little bit better?
Yes, ma'am.
Okay, Noxie. So Z says, if equal chords subtend equal angles, I thought that O1 equals 40. Angle O1 will be double angle A1 because of angle at center is twice angle at circumference. Yes, that's true, Ntando. T1 plus T2 plus T3 is 180 degrees. Okay, so now back to where we were before, all right? We can see that angle T2 is, would you be wrong if you said that C2 was 100? Yes. Why do you think that C2 is 100? Can I take you back? Why is angle B? Oh, yes. Sorry, we didn't write our reason. I beg your pardon. Quite right. Okay, so let's put that in here. Angle B1 plus B2 is equal to 75, right? Because it is the opposite angle to this cyclic quad. Okay, so TABC is a cyclic quad. It has 4 points on the circle. Okay, so because angle B1 and B2 is opposite angle T2, it means that B1 plus B2 is going to be 75 because the two of them together add up to 180. Okay, so here our reason would be opposite angles of cyclic quad. Absolutely. Just give me 1 second. Coco, would you like to take them through the next one?
Sure, ma'am.
Okay, just give me 2 seconds.
No problem. All right, guys, does anybody have any idea what C2 would be and how we would get there?
Yes.
Okay, I'm seeing Nobuhle and Kutlwano. Okay, Kutlwano, would you like to unmute and walk us through your I'm sorry, guys. Lee is the one who has the pen to write. So I might not be able to write for you guys, but we're going to have a bit of a conversation until she comes back, if that's okay with you guys. Okay, Kutlwano, would you like to unmute?
Yes, can you hear me? My Wi-Fi.
I hear you perfectly, thank you.
Okay, so like I got C2 as 15.
Okay, and how did we get to 15?
I don't know if this is the right way. I kind of took the long way. I said A1 and 2 is supplementary to C1, 2, and 3. So it would be equal 180. And then I began by subtracting A1 and 2, which is 80. And then I subtracted 50 because I calculated C1. And then I subtracted 35 from being C3.
Okay, that's wonderful. How did we get C1 though?
I got what you call this now? O1 because of
because angle at the center is 2 times the angle at the circumference.
That one. And then since O1, since OB and OC are radii, they're equal, which means this is a what you call this now? An isosceles triangle, which means angle C1 and B1 would be equal. And then I just used the angles in a triangle to get C1.
Okay, awesome. Understood.
That sounds good.
It does. And Ntando, the way she found C3 is she took the triangle ATC and she calculated C3 from there because that's the interior angles of a triangle.
100%.
And I'm hoping I'm hearing you correctly. I'm sorry, Lee, I couldn't write. I realized you've got the...
Oh, yes, sorry.
Yes, and then what she used was the opposite angles of a cyclic quadrilateral, which would have then been equal to 180. She went a very roundabout way, but Kutlwano 100%. Very well done.
Yeah, no, absolutely.
Calculated on my side, but your method is quite correct.
Absolutely. And unfortunately, with this particular question matrix, this is actually not a very nice question because it is actually quite long. There isn't really a short way that we can answer this. So well done on saying that. But just to finish this off, let's do this with everybody. Okay. Thank you for your patience with me. All right. So matrix, can we see that angle O1 is the angle at the center And chord BC subtends O1. It also subtends A1 at the circle, all right? So what we could start off by saying here is that angle O1 is going to be twice of angle A1. So O1 will be 80. Reason, angle at center equals 2 times angle at circumference. All right, then this is, I just caught the tail end of this. This was perfect. And line OB is equal to line OC because they are radii. Therefore, B1 equals C1 because they are angles opposite equal sides. So what I could do here is, hang on a second. So yeah, we do need to know how big that is. Okay, so what that means
from here, what we can do is, because we have A1 and A2, all right, and we have what?
Yeah, so we know that that's 80, right?
Yes.
We know that that has to be 100.
Yes. Okay.
So you said somebody worked out the size of C3 using angles of a triangle, which would be correct.
So if you look at ATC, you're going to get 180 minus 105 minus
correct.
40.
Yeah.
That will give you C3. And C1, because we've got isosceles triangle, angles opposite equal side, B1 and C1 will be equal. Therefore, you can calculate C1, and whatever from that will be C2.
Absolutely. Absolutely. Yeah, no, that's exactly it. That it would be the shortest way that you would be able to do this. So yeah, I mean, you would now have to work out. So what you could do is, if you wanted to say let that one be X and let that one be X, in order to work out what C1 is, you're going to have 2x plus 80 equals 180, and that's because of the angles of a triangle. So that means that X is going to be equal to 50. So now you know that C1 is going to be equal to 50. You've already worked out what ATC is. And now you would have 80 plus 50 would be C1. C3 is 35. No? How big is C3?
Yeah, it's 35.
Yeah, 35, okay. So plus 35 plus C2 would add up to 180. This is because of the opposite angles of a cyclic quad or supplementary.
Yes, ma'am.
Sorry, guys. So then that means that angle C2 would be equal to 15. Did I do that right?
Yes, ma'am. 15.
Okay. So C2, let's just move this up a little bit. C2 is 15. Yeah, so unfortunately, that's a little bit of a long one. There wasn't a shorter way to be able to do that, but there we go. Okay, so how are you feeling, Matrix? How's grade 11 circle geometry sitting with you now? You can give us some emojis so we can see how you're feeling.
Or maybe a mark out of 10, and we can see kind of how 10 being I'm really okay with it, I'm not confident, 1 and 0 being I don't see anything, just gibberish. How about that? You can pop that for
That's
us.
a far better suggestion. Thanks, Coco.
Jamie says 9 out of 10. I'm seeing 8 out of 10. This is good. This is really good. Timela says 5. Oh. Noxie says 6. Okay. So at the moment we're seeing about nothing less than a 5 out of 10, which is good.
Oh, that's good, Roro-san. Okay, Keith, you've got a hand up. What would you like to ask us? Go for it, Keith. Thanks, Balungile. Thanks, Luyanda. Keith, was that maybe a mistake? All right, so we are going to continue with this afterwards, but it's now time for you guys to go and try the quiz. The quiz is super, super easy. It's literally true and false, and it's theory questions. All right, so it's all theory based on what we've spoken about today. All right, so tangent, and then also from last week as well. So in other words, it's just based on grade 11 geometry. So go and give that a try, and then we will get started with the next lesson promptly at 6 o'clock. Okay, you shouldn't need more than 3 minutes to do the quiz. It's very, very simple. Okay, and then we'll see you after the break.
Thank you so much.